The National Electrical Code, or NEC, specifies how to properly ground a vehicle connected to a portable generator via an extension cord. The NEC mandates that cord and plug connected equipment be grounded through the grounding conductor within the extension cord. Using an extension cord equipped with a grounding conductor, typically a green or bare wire, is essential. Connect the grounding conductor of the extension cord to the grounding terminal on the vehicle using a suitable grounding clamp. Ensure the other end of the extension cord is plugged into a properly grounded outlet. Installing a ground rod directly at the vehicle is prohibited. Firstly, doing so can create a ground loop, which compromises the effectiveness of circuit-protected devices. Secondly, it can increase the risk of electric shock if the ground rod isn't installed and maintained correctly. Thirdly, it is not a recognized grounding method for cord and plug-connected equipment. The operating instructions for the equipment must clearly state the proper grounding procedure. Firstly, the vehicle must be grounded by connecting the grounding conductor in the extension cord to the grounding terminal on the vehicle. Secondly, installing a ground rod at the vehicle is strictly prohibited. Thirdly, only extension cords with a grounding conductor are to be used. Besides proper grounding, several additional safety measures are crucial when using electrical equipment, particularly with explosives. Firstly, regularly inspect the extension cord and grounding clamp for any signs of damage. Secondly, maintain a safe distance between the equipment and any flammable materials. Thirdly, adhere strictly to all manufacturer's instructions. Fourthly, be acutely aware of the risks associated with static electricity and implement appropriate measures to mitigate those effects. Ground loops occur when there are multiple paths to ground, creating the potential for current to flow through unintended paths. This can interfere with the proper operation of circuit breakers and other safety devices. For example, if a vehicle is grounded both through the extension cord and a ground rod, a ground loop could form. If a fault occurs, the current might split between the two ground paths, potentially preventing enough current from flowing through the grounding conductor to trip the circuit breaker. This could leave the vehicle energized and create a shock hazard. A properly grounded outlet is an outlet that has its grounding terminal connected to the building's grounding system, which ultimately connects to the earth. This connection ensures that any fault current will flow back to the source, tripping the circuit breaker and energizing the circuit. The grounding conductor in the extension cord provides this path from the vehicle to the grounded outlet. Inspecting the extension cord involves looking for any cuts, abrasions, or other damage to the insulation. The grounding clamp should be checked to ensure it is securely attached to the vehicle's grounding terminal and that it is free from corrosion. Any damaged component should be replaced immediately. Flammable materials should be kept away from electrical equipment to prevent fires. This includes gasoline, propane, and other similar substances. Manufacturers' instructions often include specific safety precautions related to the equipment's operation. These instructions should be followed carefully to prevent accidents. Static electricity can be a significant hazard in environments where explosives are present. Static discharge can ignite flammable materials or detonate explosives. Precautions to mitigate static electricity include grounding all equipment, wearing static dissipative clothing, and controlling humidity levels. In general, bonding means connecting all metallic parts of a system together to create an electrically conductive path. This ensures that all parts are at the same electrical potential, reducing the risk of electric shock. Grounding, on the other hand, connects the bonded system to the earth. This provides a path for fault current to flow back to the source, tripping the circuit breaker. In the context of the question, the vehicle's metallic parts should be bonded together, and then the entire vehicle should be grounded through the extension cord's grounding conductor. The NEC provides specific requirements for grounding and bonding in Article 250. It covers topics such as grounding electrode systems, equipment grounding conductors, and bonding jumpers. Adhering to these requirements is crucial for ensuring electrical safety. The instructions provided to the equipment operators should be clear, concise, and easy to understand. They should emphasize the importance of proper grounding and the hazards of improper grounding. Regular training should be provided to ensure that all operators are familiar with the correct procedures. The grounding terminal on the vehicle is a designated point for connecting the grounding conductor. It is typically a metal stud or lug that is electrically connected to the vehicle's frame. The grounding clamp should be designed to securely attach to this terminal and provide a reliable electrical connection. Extension cords should be chosen carefully to ensure they are suitable for the application. They should be of the correct gauge to handle the current required by the equipment and should be rated for outdoor use if necessary. Consider the length of the extension cord. Longer cords can cause voltage drop, which can affect the performance of the equipment. If a long extension cord is necessary, a heavier gauge cord may be required to minimize voltage drop. Ground fault circuit interrupters, known as GFCIs, are devices that detect ground faults and quickly interrupt the circuit, preventing electric shock. They should be used in any location where there is a risk of electric shock, such as outdoors or in damp environment. Surge protectors protect equipment from voltage spikes and surges, which can damage sensitive electronics. They should be used to protect any equipment that is susceptible to damage from voltage surges. Lockout-tagout procedures are used to ensure that equipment is de-energized before it is worked on. These procedures involve locking the circuit breaker in the off position and tagging it to indicate that the equipment is being worked on. This prevents the equipment from being accidentally energized while it is being serviced. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Local electrical codes may also have additional requirements. The authority having jurisdiction, or OJ, is the organization responsible for enforcing electrical codes. This is typically a local government agency. The AHJ can provide guidance on specific code requirements and can perform inspections to ensure that electrical installations are compliant. Consulting with a qualified electrician can help to ensure that electrical equipment is installed and operated safely and in compliance with all applicable codes. A qualified electrician has the knowledge and experience to identify potential hazards and to recommend appropriate safety measures. The goal of proper grounding is to provide a safe path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. This prevents electric shock and reduces the risk of fire. Improper grounding can create a variety of hazards, including electric shock, fire, and equipment damage. It is essential to follow all applicable codes and regulations to ensure that electrical equipment is grounded properly. Static electricity is the buildup of electrical charge on a surface. It can be caused by friction, induction, or other means. When a static charge builds up, it can discharge suddenly, creating a spark. This spark can ignite flammable materials or detonate explosives. Bonding is the process of connecting all metallic parts of a system together to create an electrically conductive path. This ensures that all parts are at the same electrical potential, reducing the risk of electric shock. Grounding is the process of connecting the bonded system to the earth. This provides a path for fault current to flow back to the source, tripping the circuit breaker. Ground fault protection is a type of protection that detects ground faults and quickly interrupts the circuit. This prevents electric shock and reduces the risk of fire. Overcurrent protection is a type of protection that protects against overloads and short circuits. This prevents equipment damage and reduces the risk of fire. Surge protection is a type of protection that protects against voltage spikes and surges. This prevents equipment damage. The NEC provides specific requirements for grounding and bonding in hazardous locations, such as areas where explosives are present. These requirements are designed to minimize the risk of ignition and explosion. In addition to the NEC, other codes and standards may also apply to electrical equipment used with explosives. These codes and standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers or IEE, the National Fire Protection Association or NFPA, and the American National Standards Institute or ANSI. It is important to be familiar with all applicable codes and standards to ensure that electrical equipment is installed and operated safely. Regular inspection should be conducted to ensure that electrical equipment is in good working order and that it is grounded properly. Any deficiencies should be corrected immediately. Employees should be trained on the hazards of electricity and on the proper procedures for working with electrical equipment. This training should include information on grounding, bonding, ground fault protection, overcurrent protection, and surge protection. Emergency procedures should be in place to address electrical emergencies such as electric shock or fire. These procedures should be practiced regularly to ensure that employees are prepared to respond effectively. The use of intrinsically safe equipment can reduce the risk of ignition in hazardous locations. Intrinsically safe equipment is designed to limit the amount of energy available to ignite flammable materials. Explosion-proof equipment is designed to contain an explosion within the enclosure, preventing it from spreading to the surrounding environment. Purged and pressurized equipment is designed to prevent flammable materials from entering the enclosure. Electrical safety is a critical consideration when working with explosives. By following all applicable codes and regulations and by implementing appropriate safety measures, it is possible to minimize the risk of electrical accidents. Remember, always consult with a qualified electrician or electrical engineer for specific guidance on grounding and bonding requirements for your application. They can assess the specific hazards and recommend appropriate safety measures. Be aware of the potential for static electricity buildup. Use static dissipative materials and equipment to minimize the risk of static discharge. Implement control measures to reduce the risk of static electricity, such as maintaining proper humidity levels. Ensure that all electrical equipment is properly maintained and inspected regularly. Repair any damage to insulation, connectors, or other components immediately. Use only approved electrical equipment and materials that are suitable for the intended use and environment. Do not use damaged or frayed extension cords. Ensure that all electrical connections are tight and secure. Avoid overloading circuits. Use the correct size and type of circuit breakers or fuses. Follow lockout/tagout procedures when working on electrical equipment. Wear appropriate personal protective equipment or PPE, such as safety glasses, gloves, and footwear. Be aware of the location of emergency shut-off switches. Know how to respond in the event of an electrical emergency. Report any electrical hazards to the appropriate personnel immediately. Participate in regular safety training and awareness programs. Stay informed about the latest electrical safety codes and standards. Remember, safety is everyone's responsibility. By following these guidelines, you can help to prevent electrical accidents and ensure a safe working environment. Ensure all electrical work is performed by qualified and licensed electricians. Regularly review and update safety procedures to reflect changes in technology and regulations. Promote a culture of safety where employees are encouraged to report hazards and near misses without fear of reprisal. Conduct regular safety audits to identify potential hazards and ensure compliance with safety procedures. Invest in employee training and education on electrical safety best practices. Clearly communicate safety policies and procedures to all employees. Provide employees with the necessary tools and equipment to perform their jobs safely. Maintain a safe and clean working environment. Promote a healthy lifestyle among employees, including adequate rest, nutrition, and exercise. Encourage employees to take breaks and avoid fatigue. Provide access to employee assistance programs for those who need support. Recognize and reward employees for their commitment to safety. Lead by example and demonstrate a strong commitment to safety at all levels of the organization. The proper grounding method involves using an extension cord with a grounding conductor, connecting it to the vehicle's grounding terminal with a suitable clamp, and plugging the cord into a grounded outlet. Prohibited methods include installing a ground rod, which can create ground loops and increase shock risks. Always follow safety measures, inspect equipment, and stay aware of static electricity risks.